It's okay.
Okay.
Okay, I think we are on now. Let me just check out if people can hear us. Okay, I think we are on now. Okay, we are on. We are live. So, hello, Tim Troutman. Welcome again to my humble YouTube channel. So, that's the second time that we have Tim Troutman here in this channel. At the last time we were talking in Portuguese and we discussing uh, Thomas Aquinas and the Summa Theologica. And today we are going to have this conversation again on Thomas Aquinas, but more specifically, we will talk about Thomas Aquinas' commentary on Aristotle's Physics, because Tim Troutman he has been making a series of videos summarizing in Latin Thomas Aquinas' commentaries on Aristotle's Physics. And I have watched all the videos that he has done there. I think he has summarized the half of Thomas Aquinas' commentary there. So there is a second half that he will make soon. So I have watched this series and I have enjoyed it a lot. I think it was very good. I'm happy because I have been studying Latin for some time and I'm already able to understand Tim Troutman's series, so I'm very happy. And his series is very interesting, very 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 good, a great series. So I would like to hear Tim Troutman's. At first, I would like to ask him why did he start making this series of videos summarizing Thomas Aquinas' commentary. I think that it's related to his study of Latin. I think making this series would help him to improve his Latin, which is very an advanced Latin. He knows Latin very well. Tim Troutman knows Latin very well. So I'd like, but there. I think there is more because Aristotle's Physics is a book very important for us to understand more. So I'd like to ask Tim, why did he start making this video? Why is he interested in Aristotle's and Aquinas' physics?
Great. Yeah, thanks for having me on again, William. Always love to chat with you and discuss these kinds of things. So much easier in English for me. So, um, yeah, I started, like you said, it was in large part because I wanted to have a project that that I could work on to help me improve my Latin. And I always find that do doing something productive helps me rather than simply just taking input and just reading or that sort of thing. I want to work on something actively. And along with that, with any language, if you're always reading books and textbooks and things like that designed to teach you the language, they're all not usually or not often discussing subjects that genuinely interest you. So I picked uh, the physics because that is a genuine interest of mine. So I'm killing two birds with one stone. I have read the physics before, uh, probably I would say maybe two times all the way through in English. I have not read St. Thomas's commentary except for bits and pieces as needed. I mean, I've read a lot of it, just not straight through. So now I'm doing a complete straight through reading of his physics. And I've audited some courses, I guess, on physics. One great lecture series that is available that people can find online is by Dr. Duane Bergquist, the who recently passed away, unfortunately, but he was a great teacher of the physics of Aristotle's physics. So
Yeah. Okay. So I have a question, a more specific question, because you start. Oh, sorry, my dog is barking here. But you started the series with a quote of Heidegger. I will ask about this quote soon, but I'd like to say two things. First, that the link to your series, I added the link to our in the commentary of this video. So if you who are watching this video, if you are interested in watch Team series, there is the link to Team series there. And the second point about the Duane Bergquist, but I will ask that soon later. So first, this quote of Heidegger, because I think uh, I don't know how many people understand the importance, how how much Aristotle's physics is important for us to understand, and how many differences there are between our current worldview and ancient worldview. But you start, as I said, your series with a quote of Heidegger, right?
mhm.
Saying that. So maybe if you would like to explain more this quote, I think it
do
would
you
be a good point to start.
do you happen to have the quote? Because I forgot to pull it up. I can go by
Okay,
memory, but
I will find the quote, but you could start talking about it, and then I
okay.
read the quote. So,
Okay. Yeah, by the way, Heidegger has a great commentary on Physics Book One. It's worth reading and it's very insightful. And especially for Heidegger, I think it's one of his works that are a lot easier than others. Heidegger can be very difficult to read.
mhm. Yeah, let me read the quote I have here now.
Okay.
So Heidegger said in Latin. I read in Latin, and you can maybe translate it into English. Liber physicorum Aristoteles, quia occultum nunquam studiose est per lectos, nec non est fundamentum ac principium philosophiae occidentalis.
And just to be clear, that Latin's actually mine. I translated it from the English, which was translated from German into Latin. So it's not exactly what he says, but it's I, I, I added a couple words. Actually, a friend of mine, my German friend Simon, helped me with he wanted to add a couple words there. He said, I think if you do this, it'll make it a little bit easier to understand in Latin. Anyway, yeah, so basically in English, the translation is that the Aristotle's physics remains the great hidden fundament uh, of uh, of Western thought, and it remains hidden because it's so difficult. And again, that's not an exact quote, just by kind of going off memory. And I remember I switched some of the order around in Latin as you do. So anyway, the point is that physics, Aristotle's physics has not been set aside because modern physics has disproved it so much as it has been set aside because it's archaic in our estimation, and it's very difficult at the same time. So some of the arguments he presents are quite difficult to wrap your mind around. It's not clear sometimes when he's making a demonstrative argument or whether he's making a probable argument, which he does both in the physics. And so there's a lot of difficulties, a lot of things that make it difficult for us and for anyone who's ever read them. In fact, if I can maybe segue into, I think what you were going to ask about Dr. Bergquist, or maybe this is, I don't know, but in fact, the book of physics was also sometimes called the book of natural hearing. And when Bergquist did his series on it, that's what he called it. He didn't even mention the physics. He said, this is a course on natural hearing. Well, what does that mean? It means, as he explained, that it was called the book of natural hearing because you need to hear the book. And you need to hear it from a teacher who's gone through this for years and years. And that's a Bergquist, not me. I'm not that person. I'm not an expert in either in the physics or in Latin, but it's just something that interests me, and I've been working through it myself for a while, and I'm trying to do a more systematic, if all too brief, um, uh, commentary on it. Or Latin words are coming up in my head to explain what I'm trying to say, and they're not going to work. So anyway, yeah, that's just something to keep in mind, especially for if someone's interested in the physics. It's not like the Nicomachean Ethics where you can just pick up the book and just kind of read it and you kind of understand what's going on. It's a very difficult work, and if you do pick it up and without any background and you think you understand it, you definitely don't understand it.
Yeah, yeah. You reminded me of Felipe Braga because I think I not only invited Tim Troutman to participate in this conversation, but I invited also Felipe Braga. He's a Brazilian guy. He's a lawyer. He knows many languages. He's very intelligent, and I think Tim Troutman. I don't know if you remember, but Felipe Braga said that he asked a question, or some person asked a question to Professor Scott Payne exactly about this natural hearing. Why does this book has this title, something related to hearing? And uh, it's unfortunate we don't have Felipe Braga here because he could uh, explain to us what happened, because he was very impressed with Professor Scott's answer, because the importance of hearing and hearing a teacher. And it's very interesting that we have this title in Aristotle's Physics. And I think I searched about it in Portuguese, but I didn't find anything in Portuguese explaining this title. I only found in English. So I think I met that people don't talk much about this title of physics, natural hearing, and I think it's a very important point. But before I move to another question, or before we develop this argument or this point, could you explain who is Duane Bergquist better? Because I think people should be interested in learn more about him, and maybe people would be interested to hear or listen to Bergquist's explanation on physics, because in Brazil people don't know him. I'm
Mm-hmm.
sure, or very few people. So before we move on to our conversation on physics, could you very briefly explain who is Duane Bergquist?
Mm-hmm. Mm-hmm. Well, I should have done more homework on it because I didn't. I don't have a very good biography of him in my memory. I do know that he has a brother, and I forget his brother's first name. They're both philosophers. So Duane is the one I'm referring to, and um, he is considered to be of the sort of Laval or River Forest school of Thomism. So he's a Thomist philosopher. But this particular school of philosophy um, is known for approaching Aristotelian Thomistic philosophy first and foremost through an approach from the physics. You learn physics first, and then you learn then you go on to study metaphysics. That's at least how they're characterized. Um, and they're also heavy on Aristotle, whereas some of the other Thomistic schools might um, lean a little bit more towards metaphysics, especially like the existential Thomists, so called. It's kind of a internal rivalry, I guess, between these two groups. But I can say that Bergquist is a name that would come up in that from within that school. River Thomist, um, Laval, um, of course, as John Dealey was also at least started out in the River Forest School as well. But I think those two took on different paths, not necessarily contrary, but just obviously Dealey went down the semiotic route, whereas I think, from what I understand, Bergquist is was more focused on Aristotelianism and that those sorts of roots of Thomism. So sorry, I can't say too much more than that.
No,
But
great. No, great, great, great. Yeah, and I have here the titles of your videos. So, for instance, the first one, Métodos cognoscendo procedendi, Subjectum scientia naturae, the second video, the Principiis naturae. But maybe you could take one point discussed in your videos and show us how it's important for us to retrieve Aristotle's and Aquinas' understanding. For instance, the difference between act and potency or the four causes. Because if you look at uh, current science, modern science, I have heard many people saying that modern science forgot uh, the final cause and the formal cause. Modern
mm-hmm.
science is only interested in efficient cause and material cause. Or so maybe if you could talk about some of the differences between Aristotelian worldview and our current worldview, but if you could illustrate it with some point that you explained in your videos, maybe act and potency or the four causes or whatever
Mm-hmm.
you wish.
Well, and I didn't go into much detail on either of those topics. I did well. I guess I did one video on just the four causes. I think, if I remember right, because that is an important part, uh, not just of the physics, but of Aristotelian thought in general. He also goes through it in the metaphysics, the four causes as well. Um, and you need to understand these things to read other works, not just of Aristotle, but also of Aquinas, and other authors as well throughout the scholastic period and leading up to that. Because once Aristotle laid these out and figured it out, it was mostly taken for granted for a long time, until the so-called Copernican revolution and the uh, Renaissance and those sorts of things. Certainly not all of his ideas, and certainly not by every thinker since then, but a lot of these points that he had, um, these fundamental divisions like act and potency, were for a large um, for the most part just taken for granted in certain ways. So it is important to understand what he means by those things, at least on a superficial level, at least, in order to move forward. Um, Even form and matter. Aquinas says at one point, almost casually off the cuff, and he's like, I think it might be in the commentary on the physics. I can't remember, but he says, remember the form and matter. These are really difficult concepts, so we can only understand them in relation to one another. So when we're talking about natural things, matter doesn't really mean anything in this Aristotelian sense, unless except in comparison to form, and vice versa. Um, so limiting our discussion here to natural things. and that seems weird to us because what we mean today by matter is is different. So we have a different worldview about um, about these terms and about these concepts. Matter, for example, for Aristotle, is a principle of potency, which means possibility. Let's say in a loose term, loose way. A lot of times, Bergquist would actually. I don't know if he ever used the word potency. Like he would use words like possibility. He wanted to express the kind of in the mode of Joe Sachs, a famous translator of Aristotle, who tried to, in his translation, he tries to recover sort of the original etymological significance that Aristotle and his readers would have understood by these words. So he wasn't potency now to us is a very technical word that has a lot of historical baggage, whereas back then he was in certain cases he was using words that were more mundane and more familiar to the audience at the time, like for example possibility. So you have certain things that are possible, and then you have certain things that are actual in a way that these two are contrasted with each other. So if something's actual, it can't be possible. I mean, it's already happened. And if something's possible, then it can't be actual because it hasn't happened yet, or that sort of thing. So once you divide being into these, this is a fundamental category of being, act, and potency. Then you can see how this is sort of the system. And I don't like the word system, but this is sort of the roots of Aristotelian thought that permeate into everything else. So the principle of act in natural things is going to be form, and the principle of principle of potency will be matter. So if you don't understand matter as in Aristotelian terms as a principle of potency, then you're not going to understand what he means by when he says matter. Because to us, again, when we say matter, we mean something physical that I can touch, that sort of thing. That's not what Aristotle meant. It's what we call matter. Something formed is something it's actually formed matter according to Aristotle. That's his point. Many of those things are really, really difficult subjects. I can give just like a real brief overview like I did now. This is far too brief, obviously, but even in the videos, what I go through is also very, very brief, especially in that first book, physics book 1. There's so much in there: form, matter, act, and potency, um, the subject of the science. And science is another word. We think that means something different for Aristotle and Aquinas. So I tried to explain some of these things as we went along, but I also was sort of forced to assume that my reader has some general familiarity with these concepts, especially given that it's in Latin, so it's already not too easy on that account. And then we're discussing a very difficult work, so that makes it even harder. And then if you don't have any background in that, I think it would just be almost impossible. So even though the series is simple and the concepts are basic, I would not recommend it for someone who's just getting into it. Let's say that.
Yeah, sure. But you are very clear in your videos. Your videos are very clear. Of course, in Latin, but they're very clear. You can understand well uh, what Aristotle understood about act and potency for causes and so on. But it's still on this point of this clarification and how it is different from our current worldview. Maybe I think you could explain about the four elements, because you talked to me. I think it was yesterday or the day before. You was commenting on this point, that also the difference between elements, because we have today, when we mention the four elements, we don't have a good understanding of Aristotle's and the ancient head with um, four elements. So maybe if you would like to explain it, because I found very interesting what you told me there.
Hmm. Yeah, well, and I'm also not an expert on this subject either, but um, our mutual friend, Dr. Michel Akkad, he's got a really great paper on Aristotelian elements, and he's got a very unique theory about it that maybe it might be good to have him on the episode on your podcast. I'm sure he'd be happy to do it.
Yeah, sure. I invite
But
him.
but in a nutshell, this is one of the main things when people say, even if they're, let's say, they're sympathetic to Aristotle, which many people today obviously are not, but even those who are sympathetic, they're very quick to say, well, Aristotle got this wrong and this wrong. Um, but that doesn't mean we throw out the baby with the bathwater. He still has good metaphysics, or some, he still has good ethics or something like that. I'm like, okay, well, what exactly do you think he got wrong? And I'm not saying, mind you, I'm not saying that Aristotle was right about everything, or that he, knew about, you know, uh, quantum physics or something like that. We have learned a lot since him, but but also we need to be careful about, how quickly we think that he or anybody in the ancient world, oh, they're wrong about this, they got this wrong. And one of the main things that people will immediately jump to is the elements. They'll say, um, oh, well, Aristotle was wrong. He thought that there were four elements. Well, we know there, I don't know, 100 and whatever the number is, I don't know, but um, and we're thinking the periodic table of elements. But my first question for anyone who says that is, well, okay, but what is Aristotle's definition of element? And I can almost guarantee you they will not be able to give you a response. They'll say, and they'll just maybe say their own definition. What we say an element are, what elements are. Well, you can't say he's wrong about elements unless you know what he means by the word elements. If he meant the exact same thing that we do by elements, and he thought that there were only four, uh, he would be wrong. If he thought that, all everything can be divided up into the number of electrons or whatever it is. I don't know much about these kinds of things. I don't know what the definition of it is today, but I can. I'm positive it's not Aristotle's. Um, and you can see when you look out in the world, that there's a great diversity of things that aren't, when he says Earth, like Earth is one of the elements. Well, I mean, anybody can just look at Earth and Earth and objects, and see that this is not just one unified substance. So there's all kinds of stuff here. So what did he mean when he says everything's uh, made of these four elements? So I don't go into this in the series, and um, I have ideas about it, but like I said, Dr. Akkad has more, and I think there's a lot of work actually to be done in this um, area in elements. But that's just one thing I would caution against, is immediately jumping to the idea that oh, they talked about things in a different way than we do. Oh, they're wrong.
Yeah, maybe we should invite Dr. Michel Akkad to participate here. Maybe we should have a conversation with him, because I think I told you yesterday or the day before, I don't remember now, but I told you that I was at the university was attending a class, and a professor that I had in the university. He had studied Aristotle, and he was talking to the class, to the students. He was saying, "Oh, there is no simple element. Said there is no simple substance in reality, because a simple God is not a substance exactly, but he is simple. So the only thing simple would be God in Aquinas and Aristotle's, uh, at least Aquinas' understanding. But
Mhm.
so if you don't think of God, there is nothing simple in reality, because everything is composed of act and potency, or matter and form. And he was talking to the students, that professor. He was talking to the student. He said, "Oh, there is no simple substance." And many students were impressed. What? How there is no simple substance? But chemistry says that there is simple substance, simple elements. And he said, "No, they are chemically simple. They are chemically simple, but they have qualities. They have a limit of matter. They have a form. They have potency. So they are not exactly simple. They are chemically simple." So that's an example that people don't understand what Aristotle means. So if we try to understand Aristotle's uh, concepts with our current lenses, if we look at Aristotle with our current lenses, we won't understand him, because what he uh, means, what he means by elements, is not what we today mean by elements. So
Mhm.
it's very, very, very interesting. So yeah, Dr. Michel Acado, it would be very good to have him here. So I have a few more questions to you, but let me take the example of Newton, the very important, very preclarus in Latin, preclarus
Mhm.
scientist. So,
Mhm.
because I think he is famous for having said about a pure space and a pure time, something like that. And it's totally different from Aristotle's and Aquinas' understanding of time and space. So,
Mhm.
how about you explain to us, or talk a little to us about this point, space and time for Aristotle and for Newton?
Well, I guess I'll just take it in the order that they go in the physics. Which is another thing that I'm doing. I'm going through it in the same order that Aristotle goes through it. Um, I, I'm just doing it because that's the order he does it. Most people don't, like they'll, because like motion, for example, or time, like he might define it here and then he goes on to a different subject and then later he come back to it and start talking about things you would think, why didn't he just continue on and go through these things? But anyway, as far as space, um, this is one of the really difficult arguments in physics, I think, in book 5, where I'm sorry, book 4. First, it talks about place and what is place, um, which is also a difficult subject. Book 4 is really tough book. So you get space, and then I'm sorry, place, the void, and then time. The void. What Aristotle is going to do is going to argue against, is going to refute the idea that there is a void. Now, many of the uh, pre-Socratic philosophers affirmed the void, that there is a void. Well, first of all, let's define what we mean by a void. It means that there is a subsistent 3D space. You have an X, Y, and Z axis, three axes, and let's say we envision like a cube or something, and you have a Y axis, a Z, and an X. Okay, and that's what we think of. Okay, there's this space that exists on its own. So that's when we say like separate or subsistent. That's what we mean. It doesn't depend on other things for its existence. It just exists in itself. Okay. Um, and we think of it. It's almost like it's a blank a book with blank pages, and on those pages you can write whatever you want. And when we write, that's putting objects into the space. So the space is like a blank page that we can write little objects into. Okay, that's that's really kind of our imagination of how what space is. I mean, that's kind of how we think about it. I think we all do. I mean, it's just natural, especially now in the computer age where you have, in the computer, it can only be represented in that way. So we take that and we transpose it onto, um, the rest of the world, in other words, to the real world. But Aristotle argues that, in fact, there is no such thing. There can't. Not only is there not, there can't be. And he offers a demonstrative argument, which is very difficult. I'm not going to go through it here. I touch on it in the series. But for anyone who's really interested in it, Dr. Um, Michael Duane, I hope I'm getting his first name right. Duane is his last name, Decaen, wrote his doctoral dissertation on this subject, ether, the void, and I think there's one more. I think it's just ether and the void in Aristotle. So he's got a great doctoral dissertation on that. Ether is another concept that's very interesting because most people think, well, we've dispersed with that idea now. We don't believe in ether anymore. So yes, kind of, but it's not been disproven. Most scientists today will tell you we don't have a need for it anymore. That means that we can do our math and that sort of thing without considering ether. Well, that doesn't mean it's been disproven, for one thing, and for another thing, there have been top scientists in the past century who have either directly affirmed it or have said that this might exist or those sorts of things. But I mean, for example, Einstein's theory of relativity, a lot of that stuff came out of sort of a response to the surprise at the Michelson-Morley experiments, where they were trying to measure the speed of the Earth relative to what? To the ether. That's what they were measuring. So, so ether is not some spooky, magic substance. It was taken, if not as something very reasonable, almost as a given in modern science up until quite recently. But anyway, I don't want to go down too far on that rabbit hole. But I mean, that's just another example of something that that can also help explain how there can be no such thing as a void. Because clearly, according to what we understand about modern physics, in the Earth, in the Earth's atmosphere, even places that look empty, of course, we say there's air. Okay, and Aristotle, of course, understood that, and he, some of his examples to disprove the void use air and that sort of thing. So even when you think there's nothing there, well, there is actually air. But we say, well, when you go out to outer space, that's air's not there, or it's whatever. But we still have the possibility of ether for one thing, but for another, even here's the main thing about the void. Even if there is nothing there, even if there's no air, there's no ether, there's no dark matter, no dark energy, what have you, it doesn't show that there is a void. I mean, it means that there's nothing there. There's nothing. So the nothing is not something. If we say, there's nothing to it. There's no existence if there's some area that doesn't have anything in it. And I mean, I know some of this does sound crazy, I think, to maybe modern ears. I mean, it sounds like it's archaic ways of thinking, and it is, but it's also much of it is much more compatible with the most um, modern cutting edge science that we have. Much of it is quite compatible with it, or surprisingly compatible. And I'll just give a brief example. I don't have the quote in front of me, but I do quote it in the series where and I'm gonna blank on his name. He's is an Italian physicist, theoretical physicist.
Let
Um,
me see. I'll see if I think I can find here. I think it was in the. Yeah, I'm going to find. I'll find the quote.
okay,
You can.
and I don't even remember the video it was in, but he, to the best of my recollection, in English, he says, general relativity it, it's actually the discovery. Okay, let me back up. When in Newtonian physics, when you take away objects, entities, dynamic entities, I think is the word. What you have left is space and time. That's what's left over. You take out, the sun, to take out the earth, take out the galaxies, remove those from the picture, and what's going to be left is time and space. Whereas, and we all think about, we still to this day that pervades our imagination about what's out there. But
Yeah,
did you find it?
the quote. I don't know if Carlo Rovelli is that.
Yes, that's one.
So tell me if it is right. Possumus dicere theoriam relativitatis generalis esse inventionem. That's it.
Hmm.
Sive. Okay, so a reading a reading Latin you explain in English, please. So
Okay.
Carlo Rovelli in the book Quantum Gravity, or in the article, I don't know, Quantum Gravity. Possumus dicere theoriam relativitatis generalis esse inventionem sive repertum quod spatium tempus omnino non extat. Secundum physicas Newtoni, atque physicas relativitatis specialis, scientia potentia removerentur, quae remanent, sunt spatium et tempus. Secundum autem physicas relativitatis generalis, scientia potentia removerentur, nihil remanent.
Yeah, Carlo Rovelli. Yeah, I mean, he's an active, um, well-respected theoretical physicist. In fact, he's one of the co-founders of the theory of loop quantum gravity, which is a main contending theory against string theory. Now, neither one of them have been proven. I don't know. I don't really follow that kind of stuff. But my point is that I mean, he's a heavy hitter. So these kinds of things need to be taken seriously, I think. Um, but yeah, I'm glad you read the quote because it reminded me of that. I kind of already said the second part of that quote, but the first part is really strong. He says we can say that general relativity is the discovery that space-time doesn't exist. So that when it's still in our imagination that that either that there is a separate space and a separate time, and these things are kind of self-subsistent. That's in our imagination, or sometimes we think of space-time as a unit. Well, for example, we say that according to general relativity, um, heavy objects or massive objects warp space-time. That's what we think. Well, in fact, no, they don't, because that's a way we can think of it, and we can do, and math can work that way. We can use this kind of as an imaginary model, fine. But in fact, they don't warp space time because there is no space time. and general relativity itself proves it. But Aristotle already proved it a long time ago. So if there's nothing, in order for something to be warped, it has to itself be something. I can warp a piece of paper because it has sort of its own separate existence. It's not, I can't warp the color blue, you know, because it doesn't have, it's not something that can be warped. I can't warp happiness or something like, because these are just things that don't, we talk of them as if they have their own kind of separate existence sometimes, but they don't. They exist in a it's not that they don't exist, it's that they exist in a different way. They exist in something, um, and to go back to, um, it's hard for me to try not to follow too many rabbit trails here, but space, time, being that it's, according to Aristotle, it's the measure of motion. So it's something that measures. So if there's no measure, I mean, if there's no motion, then there is no time. Time is, so you need motion first, and then you get time. I mean, they end up happening simultaneously, but secundum rationem. There's a logical order to it. Motion's first. Well, there's no motion unless there's mobile things. So before motion, you have to have something that can be moved or that is moving. Well, in order to have something that is moved, you need to have something that can be moved. You know, and so forth. So there's a priority to these things logically and ontologically, which is more important, I think, for our present purposes. So, but again, everything that what Aristotle is saying is compatible with, at the highest levels of, modern science. Now, I'm not saying that you go out and ask modern scientists that you're going to get um, them saying, "Oh yeah, Aristotle was right about everything." That's not the answer you're going to get. But insofar as those who, I think, understand Aristotle well and understand modern science very well, I think you're going to find a much higher level of agreement than is in the popular imagination. And I will offer another example of this kind of thing. There's a Brazilian theoretical physicist by the name of Juliano Neves, um, who again might be a great guest to have on here. And I was actually working on a problem um, when dealing with the generans, or in Latin, or the giver of the form, as it's often translated, as the mover of heavy bodies, because this was a debate. Going back to like Avicenna, he interpreted Aristotle as saying that the substantial form, is what moves heavy bodies, and because they had to think, when you're asking these the four causes, well, why? What's causing this rock to fall down when I let go of it? Today we say gravity. Back then they would say gravity, because you know what gravity means? It just means heaviness. And in fact, he did say that. If you ask him what is it, what brings it down, it's like heaviness. It goes down because it's heavy. But there's a philosophical question behind it. And natural philosophy and physics, are not as nearly as separated today as or then as they are today in the minds of people. So there's a philosophical question going on here. What's moving this? What's causing this to move? And by the way, Newton didn't solve this problem, and he said he didn't solve the problem. Now we think of him as having said that he did. In fact, he said the very opposite. What Newton did was not to discover that he didn't discover gravity. The first caveman who walked out of the cave, he discovered gravity. It's something that immediately presents itself to us. Um, Newton, and not to take away anything from, he's a brilliant scientist and did make a huge number of, you know, earth-changing contributions, obviously. But he wrote a letter to somebody. He said, "Oh, here's my calculations for gravity. It solves all these problems about, especially with the motions of the heavenly bodies and that sort of thing. But what I do not pretend to know is the cause of, or what causes this. I don't, or and I'm kind of paraphrasing here, so I don't know the exact wording. what happened was with Newton, his sort of popularizers um, really spread the idea of this kind of spooky motion at a distance, as I think Leibniz would go on to criticize it for. But really, that wasn't Newton himself. That was more of his popularizers. Whereas it's not that like a large body has a tractor beam and pulls this smaller or less massive object to it. And Newton never really made that claim. It's just that we can think of it in those terms, but mathematically, here's what happens. Here's the rate it comes. Here's the rate that larger objects appear to affect smaller objects, and that sort of thing. But measuring something and explaining it with causal precision, those are entirely two different
Yeah.
things.
Yeah, I have here Newton's quote, but in English. I found it in English
Okay, great.
because it became famous. In Latin, hypothesis non fingo, or
Hmm.
translating into English, I frame no hypothesis, or I contrive no hypothesis. So Newton here a quote in which Newton says exactly what you just told. So Newton says, I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypotheses. I do not create hypotheses. For whatever is, I not for whatever isn't deduced from the phenomena must be called a hypothesis. And hypotheses, whether metaphysical or physical, or based on occult qualities or mechanical, have no place in experimental philosophy. In this philosophy, particular propositions are inferred from the phenomena afterwards rendered general by induction. So he says that he doesn't know the reason. He knows how to quantify, how to measure, but he doesn't know the reason
Hmm.
for this phenomenon.
And also, I mean, it's also it's worth mentioning. It's not simply measuring, but also, like you said, quantifying, and it's also predicting. I mean, they do have predictive. You can use just Newton's equations, and they predict very well in limited cases, and those limitations are very very big as far as we're concerned. I mean, uh, you know, you, I'm no astrophysicist at all by any means, but I know once you get to a certain level, the equations stop working as well, and eventually that's where relativity comes in and starts to make sense of some of those things, and which relativity has been a extremely successful theory. Um, so and so is quantum physics, and those two don't always line up exactly, but interestingly, and this is a point that I'm by no means the only one to be making this, that the world has at first around the time of Newton and before then, Aristotle was getting pushed off to the side. Said, look, we discovered he was wrong about all these things. He was just a simpleton, didn't do experiments and didn't know about science, and et cetera, et cetera. Well, the tables have kind of turned, and Edward Fazer, who is a Thomist, kind of Aristotelian Thomist, and also I would say popularizer of, and I don't mean that in a negative way, um, of Aristotelian Thomistic philosophy. Um, he wrote a book called Aristotle's Revenge that was published, I don't know, within the last 10 years, I think. Um, and that's it's a good it's a good read, especially for if people just want. It's a big book, but it's also very easy to read, and he goes into a lot of these kinds of things. So I think you'd asked me a question earlier, and I was answering it, and I think I started going off on tangents, so I can't remember where we were going. But if I missed
No,
something,
I
let me
think
know.
that's no. I don't remember. I don't remember, but I think that was the you answered my question. But two last questions, two final questions. Uh, Today, when we imagine the cosmos, and if you ask a person to imagine the cosmos, that person will imagine the galaxies, stars, sun, and so on. Like the image I used here to as in this video, I put an image, I added an image to this video, and there is this image of the cosmos, of a galaxy, Milky Way, and so on. But we Aristotle's cosmos, of course, to our cosmos in regards to quantity, we know that the cosmos is bigger and bigger and bigger than Aristotle's understanding. But our cosmos is bigger only in extension because we forgot, for instance, the separate substance, the angels, even the reality of persons, personal reality. So when you imagine the cosmos, you imagine constellations, stars, planets, whole what is the name? Buraco negro in English. How do you say?
Black hole.
Black hole, and so on. But you don't imagine. We don't imagine persons. Person is something like we is separate from the cosmos. Totally strange. Our current image of the cosmos. So maybe if you could uh, talk a little more about the Aristotle's. Well, the image I want to bring is we have the image we have in our current image of the cosmos is horizontal. Horizontal. We have extension quantities. The as similar. It's similar to what René Guénon said. O reino da quantidade, the kingdom of quantity. But in Aristotle's and Aquinas' view of the cosmos, we could say a vertical cosmos. We have a cosmos that have hierarchy. So you start from matter, from nothing, from void, to the top, which would be God. But you have angels, and you have humans, and you have animals, and you have the demons, and so on. So we have a bigger cosmos, but a bigger in a vertical way. So, but our current cosmos is bigger, but in horizontal way, only in quantity. So if you could explain more about it, would be good. I would appreciate.
Yeah, I think that's great, and this is a point that John Dealey made once, that I always stuck with me. It's like one of the things that we have to to consider is that, at this time, and this at this time can be almost any time within more than 500 years ago. Nature was so much more imposing on your daily life, um, than it is today. Today we live in such a world of, we we forget like how much, or what it when you ask somebody, like you said, what's space like, what's outer space, or what are stars like. I think it's hard for most of us to understand how much of our answer is going to be colored through what we've been told and what we believe, which may all be completely true, but that's not what we see. It's not. Um, Now, let's say if someone said the Earth is not moving and it's it's the center of the universe. If I told that to you, or I told that to the average person on the street, they might laugh at you and say, "Well, that's the stupidest thing. No one can be that stupid." Like, well, I mean, it's this is what it looks like. It was very difficult to discover that, even when we had it required very advanced instruments that took a long time to be invented before it could be proved. Even in the time of Galileo, it wasn't. It was still a hypothesis. I mean, turned out to be right, but to really prove these kinds of things, you need to have very sophisticated instrumentation, and you're not stupid for looking around you and seeing, well, it doesn't appear that we're moving. It looks like the stuff around us looks like that's what's moves. um and on that point too, I think another thing to remember is, like, well, we think of them as, oh, they were so superstitious and so silly, they thought that the stars um affected all these things on Earth, and the planets and all this kind of things. Well, it's like, well, no, hold on a second. What they really said was that the motion of the stars and the planets affects has great effects on Earth. They didn't just say that it coincides, like this motion coincides with things that happen on Earth. It actually causes it. And it turns out they're exactly right. It's just that we're looking at it from two different perspectives. And if you don't believe me, just think about what would happen if the Earth just stopped rotating, stopped going around the sun, and it stopped spinning. What would happen? Would there be an effect? Yeah, there's going to be some effects. I don't know what they are, but so, but just notice the wisdom there, that they may have been wrong about perspective wise, but they did understand that the motion of these stars that they're witnessing with their eyes ends up being, the Earth spinning, but the motion that they're witnessing, appears that they're going to does not only coincide with events that are happening on Earth, but this motion is somehow causing or is related to these events. That's extremely wise, in my opinion. Also, I want to push back a little bit on, you said that there, our universe is bigger. Even that, I don't know. Even that, in De Cello, Aristotle argues. Um, he's like, look, these stars are of extreme size that we can't even comprehend. They're much, much larger than Earth, and they could see more stars than we can because they didn't have light pollution. So that you look out in a naked night sky with no light pollution around, and the amount of stars that you can see, most of us never get that opportunity in our lifetime. Uh, but if you can see it, it's like, wow. There's so much that we don't see on a normal basis, but when you can, that's what they're looking at though back then. And so they see all these stars, and they know that each one of these tiny little dots, um, well, Aristotle knew that they're much, much larger than the Earth. So anyway, I mean, it is true that we have like a calculated, here it's this many millions of light years away and that kind of thing, and they didn't even have really those concepts, um, but they, he understood. Of course, Aristotle makes an argument for the Earth being round in the same work in De Cello. But he makes the argument that, or that the stars. I can't remember the exact argument that he uses, but they have to be of this giant size that is incomprehensible to us. Um, so even those kinds of things, he knew we lived in this giant space. But again, back to your point, that's all extension, and that's, no matter how big you believe it is, it's still on a horizontal dimension. So you lack that vertical. I think towards the end of the physics, we'll get to a little bit more of that vertical in there, I think. Um, but it's really the work of the physics still is, it's fairly a horizontal book, I think, for the most part, because um, the physics is, you have math is the consideration of quantity without any um, reference to sensible matter, whereas physics is considering quantity as subject to motion. So motion is key here. But and that's similar to what we would say for modern physics too, right? The physicist today, he's measuring, he's concerned with how do things move and how do they interact with each other and how do they cause movement and that sort of thing. So it's similar, but there's obviously differences in how they would define it. Um, but yeah, I think, just to get back to your question real quick, to summarize, I think um, it's a great exercise for us all to try to appreciate um, the worldview of a hierarchical universe. This thing depends on this, and there's a purpose and there's an order to it. And there's arguments for these. Um, he's not just saying, oh, hey, let's all believe in gods and let's do the rain dance and it all. Um, he's not just postulating that there's an order. He makes arguments that here's why it's ordered and that sort of thing. So some of that he does in the physics, especially book 2, but I think he'll get more into that in De Cello, which is the next book.
Yeah, interesting. You were mentioning that we are separate from nature more and more. We are living in our mind, more and more in our mind and in virtual realities, and we are distant from nature to the point that we don't have more this contact with a sky without pollution, without light pollution. So we can see the sky with a lot of stars and the Milky Way. It's a very, very good point. And and you also mentioned the symbolic view of the cosmos that they had, because the relation between the stars or the movements of stars, position of stars, and some things that happen to us in our world, now in the human world. There is a causation or there is some sign. So that's a problem that we have, but they tried to not explain, but they tried to uh, live this relation between stars and our world with astrology. So the problem of astrology, because for instance, I know that the Catholic Church condemned astrology because astrology is very dangerous. I know I know it. Astrology is very dangerous, but there is some reality. There are reality in astrology. I know this as well, because if you, I don't know, Tim, if you have read something related to the, read anything related to this, but there are some calculations. You make astral map astral, an astral map, and
Mm.
you make some calculations, and you can discover the temperament of a person who you never saw before. You only look at the astral map of this person. You make some calculations, mathematical calculations, and you can discover the temperament of that person. Why does it work? I think that's a mystery, but it works. So, but there is problem with astrology. It's a very dangerous practice. I don't think people should practice it, but some kind of knowledge that there is some correspondence between human world and celestial world. I think it's a thing that we should retrieve.
Yeah. Well, I just to make a quick point, I wouldn't say that the Catholic Church has uh, banned astrology. It's just there's a certain type of astrology where when it's getting into superstition or when it's getting into you know like the modern use of the word occult, where it's demonology and that sort of thing. Those things are obviously banned, but also superstitious. So like simple horoscope. But I mean, even things like the horoscope. There, and I don't read horoscopes, and I don't really believe in that, but I do believe, like you said, that there can be um, it at the very least there can be associations. If you're born in um, if you're under this sign, for example, you might be born in the winter. Well, if all the North American people are under this sign are going to be born in the winter, the people in South America or below the equator are going to be born in the summer under that sign. So there may be some things that just on that, and I'm not really commenting on what you said to it, but just from there can be causal relations, um, or even if not causal, there can be what's the word correlation. But anyway, I think we're drifting off into a different subject.
Yeah, no, and the last point I think I asked you last year, I don't remember, about Wolfgang Smith, and you mentioned doctoral dissertation of a person who wrote a dissertation, and he mentioned Wolfgang Smith's works, and
hmm
he made some critiques. I don't know. Do you remember the name?
Um, I don't remember that name, no, but I have it somewhere. And he was not, completely against Wolfgang Smith. And he did say that some of the things he said were valuable contributions and that sort of thing. But he said ultimately, I'm just paraphrasing from memory, but he didn't think Wolfgang's solution adequately got to. And if I remember right, this is getting back to, I think it was mainly dealing with form and matter, which clearly is a big, it's important in the physics. But the other thing about the physics we have to remember, it's not, form and matter is not really what the physics is about. It's about, physics is about motion, and we need to have some basic understanding of form and matter, certainly of act and potency, to understand motion, or to define it. But it's not precisely about that. So he doesn't really, there's not a, that's, if you really want to get into that, you need to go into the metaphysics to really discuss form and matter uh, in themselves, and certainly act and potency. But those are all very difficult subjects. But that's what I think the author was getting at. That was the subject of the dispute between him and Wolfgang Smith. But if I can find that, and I could send it to you if you could put it in the comments or something, if that's something you want to look for.
Yeah. Okay. Yeah. Very very good. So you who are watching this video, if you are interested in, if you know Latin, or you are interested in improve your Latin, and you are also interested in philosophy, in physics, you should watch Tim's series. It's a brilliant series. I really enjoyed watching those videos. I'm looking forward to watching the next half of your videos. So thank you for being here. Maybe more at more closer to the end of the year. Maybe we could make another conversation to discuss Latin specifically. You could share some tips, or some algumas dicas, some tips with people that are interested in improve in learn and improve Latin, maybe closer to the end of this year. So thank you so much. Don't know if you have anything more to say. Want to say?
No, just thanks for having me. It's been fun, and yeah, I look forward to talking maybe next time. Uh, so
Okay. So thank you so much.
thanks. Bye bye.